Alright, today's lesson deals with trapezoids and kites. So, the other shapes we've done in the past have been quadrilaterals that you're really familiar with. You're really familiar with squares, rectangles, and a little bit with rhombus. Now we're talking about trapezoids and kites. So here's a basic trapezoid. I'll draw one out to the side. This is how they're pictured a lot of times. And the key fact about a trapezoid is that it has one pair of opposite sides parallel. So it has one pair of opposite sides being parallel. Only one pair. The other pair, definitely not parallel. So some keywords now. Bases of a trapezoid. The bases are the parallel sides. Those are the parallel sides. So this would be a base, and this would be a base. From here we have some base angles, and there are two sets of base angles because we have two bases. The base angles are angles on the base, or on each base. So there are going to be base angles down here, and then there are going to be angles up here. Lastly, we have legs, and these other sides are the legs. So the non-parallel sides. The non-parallel sides. I should have these with all different symbols. These are all different angles. So maybe put 1 mark, 2 marks, 3 marks, 4 marks. Yeah, they're definitely not the same down here. So those are all different size angles. Thanks. We also have an isosceles trapezoid. And this one is really nice. It has a bit more symmetry than just a regular trapezoid. So here's what it looks like. Its legs are going to be congruent. So this one has a bit more symmetry than the other trapezoid we saw earlier. Earlier, the legs were not congruent, but now they are congruent. And that's why it's called an isosceles trapezoid. The legs are congruent. A trapezoid in which the legs are congruent has a lot more symmetry. Mid-segment of a trapezoid is a really nice way to show some math on a trapezoid. Mid-segment. What's that mid word make you think of? Middle. So if I find the middle of these legs and create a midpoint, I can then connect the two midpoints, and I've created the mid-segment. So how would I describe a mid-segment? Well, you draw the midpoints, on the legs, and then you connect the midpoints. So you're probably thinking, why is that useful? Well, if this piece is 4 units long, and this one is 8, does anybody have a guess at how long the mid-segment is? It is 6. So those of you who did that in your head, how'd you get that? Well, a lot of people do this. 4 plus 8 divided by 2. What's it called when you do that? It's the average. It's the average of the two bases. The mid-segment is just the average of the two bases. You might want to write that down. Mid-segment is the average of the two bases. So 4 plus 8 divided by 2 is 6. Our last shape we got to talk about is a kite. Typically a kite Looks something like that. What do you think the key properties of a kite are? Anybody remember? Anybody know? I'll tell you a few real quick. One pair of opposite angles are congruent. And there's one more. Kind of two more. What are these things called in green? Those are diagonals. Do the diagonals bisect each other? Well, this long one bisects the short one, but does the short one bisect the long one? No. So we can't say diagonals bisect each other. However, we can say diagonals are perpendicular. Diagonals are perpendicular. One more dealing with the sides. Can anybody see anything dealing with the sides? Yeah. And these are consecutive sides. So these two short ones are congruent and these two long ones are congruent. So two pairs of consecutive congruent sides. Of consecutive congruent sides. So on this one, example 1, it says show that shape is a trapezoid. The two key things you got to remember. We're going to be talking about slope, and we're going to be talking about Pythagorean theorem or distance formula. These are the two things we're going to be proving on this problem. Now remember, if it just says prove the shape that it's already telling you it is, you need to think about its properties. What's the main property we need to talk about for a trapezoid? We've already said it today. One set of parallel sides. One pair of parallel sides. That's the property you got to prove to make sure it's a trapezoid. I only want one pair of parallel sides, not two pairs. One pair of parallel sides. So I see it already in the picture. I see this DE and CF. I want to see if those two pieces are parallel. How do you find the slope of this piece up here? What do we start with, D or E? D, because it's the leftmost. So from D, I count up or right? Up 1, right 3. So that's a slope of 1/3. The other piece, do I start with F or C? C is the leftmost, so I start here. So it goes up 1, 2, and right 1, 2, 3, 4, 5, 6. And that's a slope of 2/6, which we know simplifies to 1/3. What can you tell me about those two slopes? Okay, one pair of parallel sides, and it's really opposite sides. Definitely, those are parallel. These slopes, real quick, prove that they are not parallel. So what's the slope of this CD segment? That's a slope of 3. We got to make sure this is not parallel to it. What's the slope over here on EF? Down to right 2. What's that slope? -1. Are these the same? Nope. That means one pair of parallel sides, and we have a trapezoid. So I proved that property right there with the math over there dealing with my slope. Here's some additional properties to remember when dealing with trapezoids. These are ones that you will be tested on, so make sure you understand these. A lot of them deals with the symmetry of an isosceles trapezoid. So 8.14, if a trapezoid's isosceles, then each pair of base angles is congruent. Is congruent. So remember, symmetry on an isosceles trapezoid. So this piece can map over to here. So B and C are congruent. What's the other congruent pair? A and D. A and D are the other pair. So that's only on an isosceles trapezoid, though. Please make sure you remember that. On a regular trapezoid, that's not true. Here's another little trick. If a trapezoid has one pair of congruent angles, and then really it's base angles, then it's an isosceles trapezoid. So right now we only have A and D congruent. They're along this base down here. Since these angles are congruent and they're along the same base, then you maintain that symmetry, so it is isosceles. So really you only need one pair of base angles to prove it's isosceles. The last one deals with its diagonals. Once again, lots of symmetry, so if I draw both my diagonals, if they are congruent, then it is isosceles. So if BD is congruent to AC, then we maintain the fact that it's isosceles. And here's how you could write these properties in shorthand. On this one, we could say both sets of base angles are congruent. So that means each of those sets are congruent. Doesn't mean they're all congruent. On this next one, only one pair of base angles is congruent. It really is needed to be congruent. On an isosceles trapezoid. And the last one. Diagonals are congruent on an isosceles trapezoid. So remember, these are all for isosceles trapezoids. I like this kind of problem. It says we have a shelf fitting into a cupboard in the corner of a kitchen, and it's an isosceles trapezoid. Immediately I remember that has a lot of symmetry. Basically saying find all the other angles. So if this one is 50, what else could you immediately tell me without any math? N is 50. So this one and this one, they're the same, so N is also 50. But now we got to figure out these two at the top. So here's a trick I'm going to teach you, and this always works with any trapezoid. So usually the base angles are congruent. Those are the congruent ones. But what we'll also learn is this. If you circle a different pair, if you circle the pair along the legs, these have a relationship. Those two are supplementary. That means they add to 180. So the two along the legs, the two angles on the legs are supplementary. So if this is 50 on N, M is going to be 180 minus 50, 130. So M is 130. Same thing over here. Circle these two along the legs. L is also 130. Draw out checkpoint number 2 real quick. All right, so on checkpoint 2, it gives us one angle on an isosceles trapezoid. Immediately, we should be able to know what angle without any math. C. C is how big? 135. These two are going to be the same. So a lot of you got that the other angles were closely related. These ones along the legs are going to be related. These two should add up to 180. They're supplementary. So how big is A? And how big is D? 45. And they should maintain that symmetry. All right, now we're going to talk about those mid-segments on a trapezoid. So we have a mid-segment drawn. It tells us it's a mid-segment. So key in on that word. Whenever you're trying to find this segment right here that's connecting the two midpoints, you should remember that it's going to be between these two numbers, 9 and 16. How do we find that number that's between them? Add them, divide by 2. So 9 plus 16 divided by 2 is 12.5. All right. One thing they'll try to do to confuse you on mid-segments is this. Draw this example real quick. I just turned it to the side so you see it in different orientation. We'll say, here we go. We have our mid-segments. Now this time, I'm going to say this is 20 and this is 15. Find the missing base. How would you do that one? Okay, I've already heard 10 blurted out. You could do some complex math, but here's my trick. How much is it getting smaller by? You got a -5. -5 more, and what do you get? 10, done. Now remember I talked earlier about some properties of kites. I talked about the diagonals being perpendicular, so that's shown in this picture. So CA is perpendicular to BD. The diagonals, when drawn, are perpendicular. They do not bisect each other. Only one set is being bisected. CA is the only piece that would be bisected, not BD. The other thing is that it has one pair of opposite sides congruent. Only one pair. Exactly one pair of opposite angles are congruent. So which two angles are going to be congruent in that picture? It tells us A and C will be congruent. What do we know about B and D? Are they congruent? They are not congruent. So put a little slash through it. Not congruent. All right, this last one is also on our test. So it's giving us some angles on a kite, and it tells us it's a kite. Now what we need to do is solve for the missing angles. So these angles are the non-equal ones. So that means that R and T must be equal. Usually when we have an unknown, we'll call it X. So if this one's X, how big is that one? X. How do you think we're going to set this up? Okay, so we know the total is 360. So that means if we do X plus 70 plus 88, they're going to total up to 360. And that's always 360 on quadrilaterals, sum of interior angles. From there, we're going to simplify, combining like terms. These x's are on the same side, so we can combine them. X plus x is 2x's. From there, we can do 70 plus 88. They're on the same side, so we just do what they say. 70 plus 88 is 158. And now it's a two-step equation that we're going to be solving for x. What do? Subtract 158. 158. So 360 minus 158 is 202. Divide by 2 and you get x is 101. How big are each of those angles? 1. Try out this last checkpoint. All right, so this last one, it gives us these two angles that are non-congruent, not congruent. We got to find the other ones. Remember, we call these the same angles, so we'll call them x and x. The fast way on the calculator would be to do 360 minus 85 minus 75, and then divide by 2 at the end. And what do we get? 100 even? 100 even. So each of those angles are 100.